So we are going to discuss data types. So when we talk about Java data types, there are two different kind of data type. One is numeric and second one is non-numeric, right? Furthermore, there is one more data type that we will discuss later on, that is called user-defined data type. Okay, so we are not discussing user-defined data type. For example, what we can have is here at this point we will have something called as user defined data type, right? I can say this is data type. So there are two data type basically. One is primitive and one is user defined data type. In primitive, we have two different kind of data type. One is numeric and one is non-numeric. So whenever we want to represent numbers like 1, 2, 10, 15, 100, something like that, so we use numeric data type. Then we want to represent something called as a string or a character of collection of a character, so we have another data type that is called numeric non-numeric data type. In this category we have two data type. One is char and the another one is boolean. So basically char is to represent characters like a, small a, b, symbol, right? So all these can be represented by char data type. Now furthermore we have boolean data type. So what exactly a boolean is? A boolean is basically uh, a true or false. So it can store true and false. Like whenever we want to take some decision, we want to store a result of a decision, like if it is true or false, we can use boolean data type. Then in numeric data types, what we have is we have two different types again, integral data type and the second one is floating point data types. Integral data type is basically to represent whole numbers, like we have byte, short, int, long. Floating point data type is basically to represent floating point numbers like 10.3, 100.7, something like that. Means where we have decimals to be considered, right? And whole numbers can be like 100 minus 100, right? These all are whole numbers. So in Java, when we say data type, there are 8 primitive data types. Let me um, read them again. First of all, we have byte, then we have short, then int, then long, then we have float, double, char, and boolean. So if someone asks like how many primitive data types are there in Java, you can simply say there are 8 data types in Java that are primitive. And the primitive data types basically are byte, short, int, long, float, double, char, and boolean. Anyone has any doubt? I'm going to explain more in detail about all these data types we have. Okay, one more thing to note here is except boolean and char, that is character, all the remaining data types are considered as signed data types because we can represent both positive and negative numbers. Like in C, what we have concept of unsigned as well. That means whatever the information we are going to store will not store sign. But when we say Java, all the data type we have except these two, boolean and character, these are signed. Means we can store both the values. Like sign will be stored with the value. Okay. Now let's discuss about integral data type. So let's first take byte data type. So when we talk about byte data type, there are certain limit we can keep inside a byte data. Like for example, we want to store a number that is 1000. So 1000 cannot be stored inside a byte. Why? There are some limitation on that. Okay, what are those limitations? Let me just write it here. Like we are talking about byte. So in memory, the byte data type takes 1 byte of memory, right? 1 byte we can say equal to 8 bit. Now let me just explore this a bit more. It's not gonna work in this way. Okay, so we have 0, 1, 2, 3, 4, 5, 6, and 7. So in total, how many blocks we have in 8-bit? 8 blocks where we can store either 0 or 1. You all know in system we can have only 0 and 1. It understands the binary number system. All right, guys. So if we take all the ones, so what value we can have is 1, 1, 1, 1, 1, 1. Okay, the leftmost bit is for sign, like whether it is a positive number or a negative number. So the leftmost bit will store sign. It will not store any information. So information can be stored only in these 7 blocks. These can be used for storing information. The last block we have, leftmost block bit, is for storing sign, like the whether the number is positive or negative. Okay, now when we say 7-bit can be used, so what maximum number we can keep here? So as we are talking about binary number, so we can convert this number into decimal. I think everybody knows how to convert it into a decimal number. What we can just do is we can take it right. We have 7 ones, 6 and 7. Okay, so I want to convert this binary number, that is 111, 111 and 1, into decimal number or into base 10. So what we will do, we will apply 2 raised to the power 0 on first place, then we will apply 2 raised to the power 1, and then 2 raised to the power 2, then here we will say 2 raised to the power 3, then we'll say 4, then 5, and then finally we will have 6. 0, 1, 2, 3, 4, 5, 6. All right, so if we add all these numbers, what we will have is, we will have 1, because 2 raised to the power 0 is 1. 1 into 1 will be equal to 1. Now we will have 2, then from this we will have 4, then 8, 16, then 32, then 64. All right, so it will become 127. Anybody has any doubt till this point? Feel free to ask, otherwise I'll move to next step. I'm talking about byte data type. Similarly, we will go with others. If you guys have any doubt, please ask. Okay, I believe there is no doubt. So I'm assuming that there is no doubt, like no one is asking question. Okay, fine. Okay, all right. So this will become 127. All right. So this is the range we can keep in a byte variable. So this is for plus, right? When we say negative number, it will be 128. Like why 128 in this case? Anybody knows that? So basically range is circular. Like we have 128 to 0 to 127 like that. So 0 is also there. That's why we can say here are 120 steps. Plus 1 0 means, yeah, that is true. That is true, Parvina. So in minus we have we can say minus 120, sorry, 120 step we have in minus, and in similar way we have 128 steps in plus including 0. That's why we are getting max can be 127. Now we were discussing one thing yesterday, like for integer we were saying there will be 2 raised to the power 31 in minus 2, 2 raised to the power 31 minus 1. Okay, because if I say, so this will be a bigger example, we have to make more calculations. So let me take this one. For a byte data type we have only 8 bit. From these 8 bit we can use 7 bit to store information. So we can write this like 2 raised to the power 7, right, in minus 2, 2 raised to the power 7 minus 1. Can we say this is similar to 128 to 127? If anybody has any doubt, please feel free to ask. This is the similar thing, because for byte we have only 8 bit. The leftmost bit is for storing sign, so we left with 7 bit. In same scenario, for integer we have 4 byte. 4 byte means 32 bit. From these 32, the leftmost bit would be for storing sign, right? The rest of 31 bit will be used for storing information, like it can be 000, 111, 100, something like that. All right, guys, any doubts so far? Okay, now let's take a small example. So range is basically circular. Let me explain what exactly I mean by circular. So we have a variable called byte b is equals to 128. I'm writing like this. So you can see I'm getting a compilation error here. Type mismatch cannot convert from int to byte because the information I'm giving here is of type int. So by default, if we write something like this, a whole number will be treated as an integer if it doesn't fit in the range of a particular data type. For example, let's say it is long. So in general, it is getting fit inside long range. That's why there is no error for at compilation time. But when I'm saying byte, we are getting compilation error, like cannot convert from int to byte, because this information cannot be stored into a byte variable. The max number we can have is 127. In this case, there is no error, right? Now, what if we want to keep this into a byte variable? There is something called as typecasting, right? I'll come to that later on, but let me just show you what exactly the circular means. So what we are trying to do here is we are saying like this is an integer, but you just treat it as a byte variable, right? And whatever the value is, is getting calculated based on the um, this conversion, basically type casting or type conversion, get that value into B. So can anyone guess the what will be the answer in B? Anyone? Max number of bytes. So max number of byte is 127. So do you mean 127, Parvina? Okay. So what I told is the range is circular. Let me just show you once again. So we have 128, right? Then we have minus 127, then we have 126, then dot 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 dot, then we have 0, and then again what we have is let's say 125, 126, 127. So this is the range we have. Okay, now what I'm doing is I'm taking 128. So directly we cannot keep it. You have seen, like if there is no casting, we cannot keep it. Now we will get compilation error at the moment we are going to write it. Okay, so what we did, we were adding cast. Now what will happen in that case? What will happen basically? So how many steps we want? We want 128, but in byte range we can have only max 127. So when we say 128, it will go here in this range, right? So we will get minus 128. If I say 129, it will go further more. We will get minus 127. I believe you guys are getting this. Yeah, max number of byte. Yeah, Parvina, you are right. We will get minus 128. Perfect. Okay, let me just run it once. So for this, what we are getting is minus 128. Let's say I'm saying 130. Now, what will be the answer? Guess, guys. I need all of your attention here. Please keep participating. We don't have Ellen today. Also, Paljit is there. All right. So we have only 11 participants today. Some of the guys are missing. Okay, 130. No. 125. No. 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 Okay. Gurpreet has given a correct answer. That is 126. Perfect. Let me just run it and show you. So we are getting 126. I believe all you guys got this concept. Okay, now what if I say minus 130? Error? No, this is simple. Like how many steps we have? 128. When we say 129, it will come here. It will say minus 127. When we are saying 130, then it will come here. Simple. Yeah. Let me just run it. So you can see 126. Any doubt in this? Anybody? Feel free to ask. Okay, let me make it more simple because I believe you are getting confused with this circular concept. Okay, so this is our watch, right? Okay, this is our typical watch. Okay, now if I say right now the time is 12, what will be the time after 1 hour? What will be your answer? One, perfect. One. Very good, very good. But what if I say like after 12 we should get 13, right? So because the range is circular, we cannot go beyond that. Okay, or if I say right now the time is 12, what will be the time after 3 hours? So we can simply say we will go 3 step ahead and the time will be this. And vice versa, if I say the right now the time is 3, what was the time before 4 hours? So we will go 4 step back and we'll say 11. You getting my point, guys? I believe that make more sense. You were getting confused here in this one, right? So now you can just say in this byte watch, what we have is we have number from minus 128 to 127, and we will go step by step. When this is this range we have computed, we will go in minus. When minus is computed, we will go in plus, like that. Okay, all right, Baljit, you got it? Okay, guys, Baljit is not replying, no problem. Okay, let me move to the next data type we have. Okay, so for byte data type, the size is 1 byte, that is 8 bits. I have explained the process like how number is going to be stored in memory, right? Because we have 8 blocks, so the data will be stored like this. We have this example that we have done here as well. Okay. All right. And I have some example for you. I think they will make more sense when you will do it like we were trying here with this, like we are getting compilation error. So basically when I'm saying c.e matlab, means compilation error. Okay, let me know one more thing, guys. You all are like native of India, I believe. If anybody has like all the time have been in US only. From India. Okay, so most of the guys, I believe, from India. Gurpreet is from Punjab. Where exactly in Punjab? Yeah, near to Chandigarh. All right. I'm in Chandigarh, Gurpreet. Okay, so I believe if I speak in Hindi in between sometime, that will not make like any trouble, you guys. No problem for me. But the guys are from South India. They might have some problem. I don't know Hindi. Yes, I was saying exactly the same thing, and Mamta just said I don't know Hindi. Oh, no problem. Hema also doesn't know Hindi. All right, not a problem, guys. Okay, now we have next data type that is called sort. The most rarely used data type in Java is sort. Like in my career, I haven't seen this one like using very much. Even I'm not able to recall like any code that I'm working on have a variable of type sort. So this is rarely used. It takes 2 byte in memory. So according to 2 bytes, what kind of data we can have is maximum minus 32768, that is similar to 2 raised to the power 15 in minus, and 2 raised to the power 15 minus 1 in plus, right? Okay, now let's take an example. In similar way, like we have sort, and I'm writing 130. So earlier when it was byte, we were getting error, but as we know, sort is a bigger data type than byte. So we can keep this information in sort data type. But what if we go beyond this? Like for this, we have the range max is this. Okay, this is fine. There is no problem at all. And let me just run it and show you the answer. Okay, we are getting the same value what we have written over here. Now, what if I say 8? It will create a problem now. Now it will be treated as an integer and we'll get cannot convert from into sort. Okay. So what we can do is we can convert using sort. So again, this is the similar thing, like we are taking 32768, but we are just going to get minus 32767. Let me just run it. Any doubt, guys? I think I told you the wrong answer. Like I said 6 7, yeah, but I was wrong, because the next step would be 68, because the range in minus starts from 32768. No, perfect. Okay, now let me just move to the next one. Okay, there is small note for you guys. So data type is best suitable for 16-bit processors like 8086, but these processors are completely outdated, and hence the corresponding sort data type is also out data type. So most of the systems we have running on 64-bit architecture, or some of running on 32-bit, right? You might have seen like there are two different architecture, like 64-bit and 32-bit. In first session we were struggling with find out the version of our window, like whether it is 64-bit or 32-bit, when we were downloading Java, if you remember, guys. Okay, all right. The next data type we have is int. This is most commonly used data type. Most of the time you are going to use this one. It takes 4 bytes in memory, and like the memory size increasing, it is going to consume more it is going to store more information. Like for byte we have some limited information that we can store, right? But 1 second, guys. You are is able to listen me? Can you hear me, guys? Okay, fine. Okay, so basically it takes 4 byte in memory. Okay, yeah, there was some issue at my end with my voice. That's why I was asking. Okay, so the number we have, the minimum we can store with int is 2147483648. That is similar to 2 raised to the power 31 in minus 2, 2 raised to the power 13 minus 1. So basically this is not the exact thing. It is the clear expression based, right? Because it should be written in a different way. Okay, so just ignore it for now. You can understand it like this. Any doubt in this? Okay, now one more thing, like we were using byte and we were having numbers like 1 to 12. Just I'm just want to store the 12 number. What we can say is like this. Now what if I want to store something called as a decimal number, which is having some decimal values after the dot or decimal point. So you can see this time we are getting a compilation error, cannot convert from double to byte. Okay, so because we are using Eclipse, we are going to get this message, this mistake. Eclipse will notify us very soon when we just complete that line. Okay, but what if we are on um, Notepad plus plus or on Notepad? So until or unless we are not going to compile it, we will not get what exactly the error is there. Okay, let me just show it once. So for example, let's assume we have this test class, and this test class is stored in my system at this place. So you can see here I have test1.java, right? Okay, let me just compile it once and we will see what exactly the error we are going to get. Java C, the name of class was test1.java. So you can see we are getting an error. Clearly it is mentioned here in test1.java line number 19. There is an error. What is that? Incompatible types, possible lossy conversion from double to byte. Means at right hand we have double, and at left hand what we have is byte. Means there is possibly loss of your information, because byte cannot store a complete a decimal point value. So that means the information you are trying to store is going to be lost, the 0.5. So when there is a risk of information loss, Java doesn't allow that, right? And it start complaining. What we can do is we can do casting, right? What is that exactly? So when we say byte, that is casting. Means here programmer or the developer is responsible, like his information is going to lost like this. So from this point we will just have 12, not this 0.5. You getting my point, guys? So that is called casting. I'll come to this again very soon, so don't worry. Okay, but the purpose of showing this one was just basically, if you work with Eclipse, error might look a bit different. Like here you can see we are getting type mismatch, cannot convert from double to byte, but on console what we are getting is um, incompatible types, possibly lossy conversion from double to byte. So don't confuse like between these kind of error, because both the errors have the same meaning, but the text is different in both the cases. All right, guys. If it were like an integer, for example 128, then you will see a different thing in error, like possible lossy conversion from int to byte, right? Here we were getting double to byte. So it all depends like what your scenario is. Any doubt in this? Okay, all right. No, no doubt. Okay, fine. Now let me take this example. We want to store some boolean value like this. So what we are getting is cannot convert from boolean to byte, but again I have to go there. And let me try to compile this one again. Josie test1.java. What we are getting here is boolean cannot be converted to byte. All right. Okay. Now the next thing is okay. There are some examples like to hold the distance traveled by light in 1,000 days. Int may not enough. Compulsory we should go for long data type. Okay, like we are taking a use case when we can use int or when we cannot. So distance traveled by light in 100 days will be a long number, like it will be like this. The value we'll get from this calculation will be the answer for this example. So obviously it's not gonna store in integer data type, because for integer we have certain limit, and what is the limit is basically this one or this one, right? Okay, so whenever int is not enough to hold big values, then we should go for long data type. So when we talk about long, it take 8 bytes in memory. So obviously it's gonna double. Not exactly double. In terms of information, it will be more than that, because it's increasing in exponent. It's an exponential growth. You can see like 2 raised to the power 1, then 2, 4, 6, right? Right, guys? So it will store a big number as well when we take long. To hold the number of characters present in a big file in may not enough. Compulsory we should go for long data type. For example, we want to count numbers, number of characters is stored in a file. So int might get fail, like if there are number of characters in that file. So in int is basically not gonna help us. So what we should use is long. All right. Again, if we are having 8 bytes, then we can simply say the range would be 2 raised to the power 63 in minus, and 2 raised to the power 63 minus 1 in would be plus, because we have 64 bit, right? The 64th bit left most bit is gonna store the sign information, whether it is a positive number or a negative number, and rest of the bit will store the information about the number. Any doubt, guys, from this till this point? Nobody has no doubt. Okay, no. All the above data types like byte, short, int, and long can be used to represent whole numbers. Means when we say byte, short, int, and long, these all four primitive data types can store only a whole number, right? And we have seen like certain use cases when to use which one. Like if you know your information is going to be stored in byte, like the number you are going to store will not go beyond 127, then obviously you can use. But whenever you don't know, then you can just go with integer. And when like your information is not gonna store in integer, then you can go with long. All right, next thing is, if we want to represent real numbers, then we should go for floating point data types that we are just going to discuss in next step. We have one message here. Okay, nobody has, no doubt. Okay. Now the next data type we have is float and then double. Okay, so if we want to store 5 to 6 decimal places of accuracy, then we should go for float. Float takes 4 byte of memory, and the range is basically minus 3.4 into 10 raised to the power 38. Right, I believe all the guys are aware with this symbol here in this. So it is basically into 10 raised to the power 38. Basically it means like that. We can write this minus 3.4 into 10 raised to the power 38. This expression can be written as well. Any doubt, guys? So this kind of information or maximum or minimum range for this is 3.4, 10 to the power 38. Any doubt, guys, in this? Nobody has? No doubt. Okay. All right. Now, float flows single precision. What exactly it means? Single precision and double precision. I'll come to that later on. Okay. Now let's talk about double. If we want to store 14 to 15 decimal places of accuracy, then we should go for double. Size it takes in memory is 8 bytes, and it can store minus 1.7, 10 raised to the power 308. That's a big number. To 1.7, 10 raised to the power 308 in plus. So that is basically the range. Okay, now we will do some example based on these, and we'll see the difference basically where a float and double make a difference. Okay, float f equals to 10.5 f I'm trying to print f. Now we have a variable called double t is equals to 10.3. We want to print this as well. Let me print d. Okay. Now I have one question for you. We haven't done yet if and else, but yes, I have something for you. For example, let me take this. If f dot equal 10 10.3 system dot output println true, else false. Okay, so we haven't discussed if and else so far, but I believe you already know what it does actually. Do you know, guys, what it does if and else? All right, Gurpreet. All right, Nagamani. Yes. Okay, just go ahead and tell me the answer. It print false. Okay. Anybody else? Okay. True. Mohammed Danis is saying true. All right. Anybody else? Nagamani, true. Okay. Okay. So let's start from Mamta. How it will print false? Like, what is the reason? Please unmute
Uh,
yourself and tell us.
yeah, for if we don't declare for floating data type safe, then it will take it as a
Mamta,
double.
please unmute yourself and tell us the reason.
Can you hear me? Hello, hello, hello. Can you
Hello.
hear? Can you hear me? Hello,
Mamta, I cannot hear you.
hello.
Can you speak once? I think you are speaking, but I cannot hear you. There is something wrong with my system. 1 second. Let me turn off season mute. I can hear. Yeah, you are right. There is something wrong with my audio. I cannot hear anyone. 1 second, guys. I think my Bluetooth is connected. Let me just turn it off. Can you speak once, Mamta?
Hello, can you hear me now? Hello.
No, I cannot hear you guys. Anyone else can speak once so that I can make sure there is something which is not working at my end. Audio setting.
Hello.
Yes, I can hear you.
Yeah.
Let's see. Pravina, right? Mamta, can you tell us like why it is false?
Hello.
Yes, Mamta, I can hear you now.
Okay. So here we in a if condition we declared a f, we assigned floating point, but we didn't mention f. So then it will take it as a double. So but
Mhm.
in above we mentioned float f is equal 10.3f, but it's not true. 10 point it is taking it as a double. So
Mhm.
that condition will become false. It's not true. So then it will go to else part.
Okay.
Then it
All
will
right.
print false.
I got your point. I
By
got your
default,
point.
it
All
is
right.
take it as a double if you don't mention f.
Okay. Now I'm
The if
changing the
condition.
question. Like, what will be happen in in this situation?
If we uh, declare f 10.25f, then it will print true.
Okay, but it is again the double.
No, it's not double. When we declared that f, then it will take it as a float. So both are same, right? Then it will print it as a true.
No, no, no. My question is like when I was saying 10.3 and I was saying 10.3, it was saying false. When I'm saying 10.25, so this value that I have selected here on my screen, it is a double.
Yeah.
So, and at the left side we have float. Now,
Yeah,
like
that's
how?
why it will give false. Can you go on this?
Okay, I think you are confused. Let me just write one more question. So this time we have one, left one. Okay, these are two different questions here. Now, from above, what will be the answer? Let me just write it here. Whatever you are going
False.
to false.
False.
Okay. In both the cases, false, right?
Yes.
Okay. So let me just run it once. All right. So in first case, we'll get true, right? And in second case, we'll get false. Let me just run it and then we will discuss like why the behavior is different. Okay, guys. So for first one, we are getting true, and the second one, we are getting false. Now, the confusion here is like, what is wrong? We are doing same thing, but answer is different in both the cases. Like ideally, it should be true, true or false, false. You guys agree or not?
Flying fish power! I need the great white shark power suit to swim with the other sharks.
No one is replying. What happened, guys? You are not responding.
As per my assumption, it will give false and false.
Okay, okay, fine. मुझे
Activate
लगता है
flying fish power!
आप enjoy नहीं कर रहे हो सेशन को. You are not enjoying at all. If you are not making it interactive, it's like you are watching a recording or a recorded video. Okay, it's up to you. Let me just discuss what are the points I want to discuss here. Okay. Okay, let's
It's
take.
interesting, Anuj, but I don't know the answer. That's why.
No, no. That is not the case. I am not interested in the answer. Answer I'll tell you. Like you guys should show your curiosity. Like we are eager to learn. We are enjoying.
No, we are eager to learn. In my case, I'm very much eager to learn, but I don't know the answer. That's why I was just thinking what could be the answer.
Okay, no problem. No problem at all.
Yes.
Okay, let me just explain. All right, guys. Okay, so let me post it here. So we have this question. Float f is equals to 10.2f. If f equals to 2.25, okay, then print true, otherwise false. Now let's understand one thing. This is a float value. Not float, sorry. It's a double value. But here it is a float. Right? So when we store a float and a double, there is some difference, little difference. That doesn't really make any difference when we say like we just note we just going to ignore our values after the decimal point like 2 3 4 and we have a number. We are just concerned about this whole number and we are just not concerned about the decimal part. But in some cases like in chemistry, right, or when you go to buy some gold, so these values matters, right? Like if some uh, in some chemical formula you do some up and down in decimal points like 2 1 3 4 5 6, like this was recommended and you make it 7 or 8, so that will make obviously some difference. You're getting my point, like what is the basic value of this decimal point. So in some cases like we are not very much worried when we are taking vegetables, but when we are buying gold, yeah, we are concerned with this number, the decimal point. You getting my point? Okay,
Yes.
so now there is something some differences when we store a float and we store a double. So let me just discuss about that. So when we say, let me take 10.25, okay, when I convert it into a decimal number, so 10 can be written like this, 1010. For 0.25, I have to convert. Like, just let me show you a small example, like how we are converting it. So for 10, we need to divide it by 2 when we are going to convert it into a binary number, and we'll write the remainder here. So 2 5s are 10, and there is no remainder. Then we will divide again. 2 2s are 4, we'll write it here, and remainder will be 1. Then we will write it again. 2 2 1s are 1. Sorry,
2.
2 2s are 4, and there will be no remainder. And then we'll finally say 1, and remainder will be what I'm missing. I think I'm missing something. 1 second. 5. Oh, it was 5. Then it was 2 here, and in this step it was 1. So this will not come into picture. All right, guys, you getting my point?
Yes.
So we will collect this number in this direction, like 1010 will become equal to 10. We can write it like this. Isn't it? We can write it like this. Okay. Now, when we come to the decimal point, so what happens in general? For whole number, we divides, but for decimal, we do multiply by 2. So it will become 0.50. Again, we will keep multiplying until we didn't get 1 at left side. So here we'll get 1.0 when we will divide it. So in 2 step, we get 1 and 0, right? A complete number. So from this, what we will say, 0 0 and 1. So it will be like we can write it like this. 10 in this 10.25 in decimal number system can be written as 10 and 10 dot, it's a dot, 0 0 1. I'm taking this 0 and this one, base 2. We can write it like this. Yeah, right. I'm checking your chat. Perfect. Okay. Now, when a number is getting sold up to 6th place, like we are getting 1 at left when doing multiplying and 0 at right, then the number is completely sold. So what we can have is like 0.001001, something like that. If a number is getting sold up to 6 calculation, we can say it will be stored in similar way, whether it is double or float. You getting my point, guys? If a number getting sold or calculated perfectly up to 6 places, then we can say there will be no difference between a double and a float. But when it goes beyond, so for float, what will happen, it will keep storing this number only. Let's say when we say 0.3, 0.3 is something like it will keep going 0 0 1 0 0 1. I'm just writing, I haven't calculated it yet, so it will go something like that. So it's not getting sold till 6th place. So then there will be difference storing the data, right? You getting my point, guys? That's why we are getting a different answer in both the cases here. So when we say 10.3, so basically in memory it is, let me just calculate it so that I can show you. 10.3 we are going to solve. So this 10 will become 1010, and for 0.3 we will have 0.6 into 2, 1.2. Then again we will say, so we will keep extracting these zeros and ones, so we will left with 0.2. So we can just say, or let me just write it as 4 here, and then again we will have 0.8, then we'll again multiply it by 2, it will become 1.6. So from this step we got 0, 0, 1. So 0 from here, 1, then 0, 0, 1, 0, 0, 1. Right, and you can see it is not yet solved, right? It will keep, because we got 6, and it will the same step we have on second place, so it will keep going. So for float it will be stored like this only, 1010 dot 001 001. So in float it is like this. Now when we say double, it will be like 1010 dot 001 001, right? And we are here at this place, so we will be getting something like 0 1 0 0 1. It will keep going until 16 place, right? So you can see there is a difference between both the numbers. This is 10.3f, and the last here we have is 10.3, or we can just write it 10.3d as well. So when we generally doesn't define this d at the suffix, so it will be treated as a double. So it doesn't really necessary to write this d at the end, but whenever you want to make a float, then this is mandatory. Like, you getting my point? So you can see these two numbers are not equal when it is a case of 10.3, but when it was case of 2.25, so the float and double were getting the same value. You getting my point, like how it is gonna work? Any doubt, anybody? Okay, anybody? Yep.
Hello?
Yep.
For the in the case of long and int also we need to mention L, right? For the long.
So when you say long and you keep some value, it is directly converted into a long, right? But when you want to tell specifically, basically you don't really need to mention that L in case of a long data type. It will be managed by Java automatically, so don't need to write anything.
Yeah, okay. That's clear.
Okay, now let's go back and see the question again. I believe you got the answer, like in first case why we are getting true, and in second case why we are getting false, because this is something 1010. I'm writing it in decimal, and what was exactly it is 001 001, right? And here what you are doing, basically you are comparing these two numbers. You are doing this 1010, and so for this point it will be kind of similar, and then again 001 001 001, something like that. So you can see both are different, right? But for this case, what we have is we have 1010 point, and it was where we did that, yeah, here 001 001, and here we are comparing 1010 dot 001 equal to 1010 dot 001. So you can see both are equal, right? Now, what if you want to make it true in this case? So what you can do is you can say treat it as a float. So when you say treat it as a float, it will become similar, like till this point. So these numbers will not be there. Okay, let me just run it. So in both the cases you are getting true. All right, so like in your if you guys are trying to sit in OCJP exam, this kind of confusing question can be there. So read it carefully and then solve it. Okay, guys. All right. Okay, now I think we have covered this one. Boolean data type. So, okay, okay. Boolean data type. Next data type we have is Boolean. So for Boolean, it takes 1 bit of memory in our system. Okay, also it varies, like depend on virtual machine, whether it is for 64-bit or 32-bit, but generally you will find it takes 1 bit, whether 0 or 1. Range, there is no range applicable because there are only two allowed values, that are true and false. Okay, and how you can make a Boolean variable? You can just write like Boolean b equals to true, and it must be in lowercase, like int, not int, Boolean b is equals to false. We can keep Boolean b1 is equals to true. We can keep Boolean b2 is equals to, we cannot write it like this. So only allowed values are false and true, and they must be in lowercase, like that only. For this you can see false cannot be resolved to a variable, right? So we cannot have a value like this in a Boolean variable, or even like this. Okay, guys, so if we do so, we will get compilation error. Okay, now generally where we will use these booleans, so whenever we want to make some decisions, right, we will be using these. Like for this expression, we'll get some Boolean value. Let me just try to show you here. If I write this here, right, let me just remove this line, and in between true and true, or true and false, you will be looking like let me just print some message here so that we can distinguish from where the answer is coming. And let me just round it with the brushes. Okay, so you can see for this I am getting true because the statement itself is giving a result in Boolean, that is true. Any doubt, guys? Because Java is gain sensitive. Perfect. Okay. Okay, in C language, you can write something like this. For example, int s equals to 1, and you can write if sorry, if X do this in C, this is a valid statement. C language. This one I'm actually talking about, not this one, because this is not applicable in C. There is something called printf function that we can use. So here is in this line we can see we are getting cannot convert from into boolean. So basically this if statement is expecting a boolean expression or a boolean value here, but in C language anything which is non-zero, like 1, -1, which is non-zero, will be treated as true. Like if it is if it were a C program, it it would have like true here with this value 1, and then it is 0, that means false. But in Java we cannot write it like this. So only expression we can write which will be evaluated into a boolean, or we can just go ahead and say true or false, right? Okay, the next data type we have is character data type. So in C language the character data type was for 1 byte, but in Java it is 2 byte. It takes 2 byte of memory. When we say 1 byte, that means the maximum number we can cover is 256, because in minus we have 128 and in plus we have minus 128 again, including 0. So maximum characters we can cover with C language were 256. But in Java, as it suppose multiple languages, right? So they have introduced a new encoding system that is called Unicode. Java uses Unicode system for numbers, so in for characters, but in C there was a standard like Sky that we were using with C language. So that was some limitation. So characters allowed were there in C language was 256, because the length or the size of a char in C language or C++ language was 1 byte, but in Java it is 2 byte. So when we say 2 byte, obviously we are going to get more numbers. How many? 65535. Basically it is 32768 in minus and 32767 in plus. So basically when we sum up both the numbers, it will come this 65535. So we are going to cover maximum number of characters, like whatever you have on your keyboard or in other language keyboards as well. All right, so Java supports multiple languages, like not just English. We can have other um, other languages we can use as well, like Chinese, German, right? So basically my point is it covers in total 65535 symbols. So everything we have on keyboard is just a symbol for us, right? Whether it is a star or a hash or a dollar sign. So you might be you might get this question like which kind of encoding system uses by Java, right? So you can say Unicode. All right. Okay. So this is quite summary of databases we have just discussed: byte sort, int, long float, double, boolean, char. What are the different size, range, corresponding wrapper classes. So a wrapper class is a different topic we'll cover later on. Every primitive data type we have in Java has a corresponding wrapper class. Like for byte, we have byte, short, integer, long, float, double, boolean, and character. And one more thing, for every data type, we have some default values. So like for numeric data type, like if you talk about specifically integral data type, byte, short, int, long, the default value is 0. Okay, and for float and double, this is 0.0. For boolean, it is false, and for character, it's a blank space. Like if you have a character variable declared and you want to print it, you will get nothing on your screen. So